Hello everyone, I'm Cibi and my registration number is URK23AI1060 and I'm going to explain my fourth experiment. First, time series prediction using recurrent neural network and first I'm importing the libraries NumPy for numerical computations like array and mathematical operations and TensorFlow for deep learning framework and Keras for sequential and simple ornaments to build and train the ornament model and minmax scalar for normalizing data between 0 and 1 to improve training performance and matplotlib for visualization and predicted output and actual output and next I'm generating the data. First, uh, np line space for generates 1000 evenly spaced points between 100 0 to 100 and amplitude 1 to slow synth wave with frequency zero point 0.1 and noise time series data. These all added, and then I'm pre-processing the data to reshape the data into columnar vector required by scalar, and minmax scalar scales all the values between 0 and 1 for better RNN performance, and I'm creating a simple output sequence converts continuous time series data into supervised learning samples, which is x equal to previous sequential length data points and y is next data point, which is the value to predict. And I'm splitting the training and testing data sets into 80% for training and 20% for testing. This reshapes data to 3D samples, time steps, and features required for format for RNN, and I'm building the data which is sequential for linear stack of layers and simple RNN which is RNN layer with 50 neurons and uses Redru activation function and input shapes 20 time steps and one feature and dense layer which is one which gives output to predict value, and I'm compiling the model. Next I'm compiling the model which gives me the efficient training optimizer which is Adam and loss which is MSC analyzes the large errors and metrics is MAE which is easier to interpret error, and I'm training the model which is trained about 20 approach for the batch size 32. This model updates weights for after every 32 samples, and the validation data helps to check the model performance on unseen data. Uh, After evaluating model, the test shows how well the model rate on unseen data with average sequential difference and average absolute difference between predicted and actual values. And this is my final output for the uh, time series data, which is green line, blue line indicates actual, and orange line indicates predicted differences. And next shows my car sales prediction data using RNN, which gives me the input. First, I'm importing libraries, same as before for time series data, and next I'm using data preprocessing, which reprocess into column format for scaling, and minmax scaler scales the value between 0 and 1 to help RNN to train efficiently, and this used to create sequences like the model used past 10 scales values to predict the next one. Using the helper function, create sequence creates x, which slides window of input sequence, and y, the target value immediately after each window. And for same for sales data includes the time series data, which gives me 80% for training and 20% for testing. This reshaped to RNN compatibility, and then I'm building a model using simple RNN with 50 memory units using ReLU function, and again one dense layer. The RNN remembers past pattern like when sales were high and what usually happens next. And next I'm compiling the data using Adam optimizer and for loss and mean square error for metrics average, mean, absolute error, and train for 50 approach. Next, evaluating the model versus how close prediction are to actual values on unseen data, and prediction visualization convert both predicted actual values to Gaussian frequency. So this is my car sales prediction using RNN. This shows the actual sales and predicted sales for this result. And next, I will show my stock price prediction using RNN. Same as before, this has uh, same libraries which is imported from time series data, car sales data. So all are same. Uh, this next time scaling the data, which normalizes price between 0 to 1, makes the model training stable and faster. And sequence creation uses past 60 days price to predict the next day's price. In stock forecasting, longer history helps to capture trends. So again, it takes 80% for training and 20% for testing, which reset again for RNN input. And then RNN model architecture differences the two stacked RNN layers. First layer returns sequentials, allows second RNN to process fully temporal info, and the deeper model used to adapt more capacity to learn complex stock trends. And I'm comparing and training the model using simpler setup, MSC loss and Adam optimism, training for 50 approach with the basis of 32. Next, evaluation using calculates the MSC loss and mean absolute error, both measured on scaled data. And this is my final visualization for stock price prediction. Indicates the actual stock price and latest stock price. Thank you.